So let's talk about vocabulary density. The code is also available in your modules. This is a computer science problem, the vocabulary density of a text. Let's just read off the definition here. The total number of words in a text divided by the number of unique words in the text. For example, let's say if you're reading a novel, this novel has a total of, let's say, 50,000 words. Of the 50,000 words that is available inside this novel, only 5,000 of them are unique. So you basically go in there and count the number of unique vocabularies, and this density is going to give you 10, so on and so forth. Scientists who study computational language, they use this methodologies to devise how unique texts are from each other. Without getting into sort of the science behind this, let's devise a software solution to solve these things. And for all intents and purposes, we define a word or a vocabulary to be a sequence of letters or characters, A to Z. It could be a lowercase a to Z or capital. It doesn't really matter. T, H, E is the same as lowercase plus the apostrophe characters. Let's say I will be considered as one word. Once you add apostrophe and letters here. So let's move on to the next page by clearing. Initialize variables objects. Depends on where you are reading this text from. It could be a file or it could be a string that came from a network object through TCP/IP, and then your services receive that text, deserialize the text, and then processing. You will initialize everything you need to get your text first. And this text is a string that has a whole bunch of words in it. It's delimited by period, delimited by commas, delimited by line breaks, and so on and so forth. Your job is to write a while loop. You set up these iterations to go through the number of words, one at a time. Once you get the word, you have this collection. And this collection is a group of string objects. What you need to do is to check to see if this particular word exists inside this collection C. So if this word does not exist, then you add the word to collection. So this is almost like a unique dictionary that stores all of the unique words that you have from that text documents. You also keep track of the total number of words. So this is at the end of this while loop, what you end up with is the total number of words divided by the size of the collection. So that size of the collection is unique number of words. That will give you the solutions that you need for vocabulary density calculation. So let's take a look at the implementation detail. There's an IO exception. This exception is throws. Okay, there's a difference between throw and throws. So throws is on the method level, whereas throw is inside the method. This basically says that whoever's implementing this will be capturing the IO exception. It will be the invokers of this application's responsibility to catch that exception if this IO runs into issues. So this IO expression is actually part of your file readers and scanner. So you might have had this from your intro Java, the ability to read off of text from a file using scanner. So once the scanner feeds in the payload coming from this file, given its file name, assuming this file exists, you then send this entire scanner into a parsing mechanism. What this parsing mechanism is, it uses what's called regex. This expression here is a regular expression, which is a sequence of characters that define a search pattern. You might have learned this in your advanced Java or some other languages. That is regex, and whatever's in there represent what we call character classes. This is basically saying lowercase a to z and uppercase a to z, but there is that hat right there in front of it. So hat means at the start of A to Z. Plus is actually a quantifier that says one or more. So your words is anything that consists of A through Z, lowercase, or uppercase, A through Z, or any combinations of them. There is at least one to many of these combinations that constitutes a word. The word does not contain any spaces, since it's not included in this character class, and a word does not and should not have any other symbols, question marks, exclamation points, number signs, and things like that. And notice that there is a apostrophe at the end. So that's the definition of what a word is in this context. Information coming in from this file is going to be coming in as a string. It's called file string. What you need to do is iterate through this file string. And since every single word would have been parsed and tokenized, they're basically as a token, each string, using the delimiter or the separators. And the way that you would get them out of it is to invoke its iterator. This iterator has next to tell you that if there is next, then iterate into the next one and get it out of the string. Every word is pulled out of that string, convert it to a lowercase, and store inside this words. This words is a concrete array collection that implements the generic collection interface. An array with a capacity, which is 1,000, that allows you to store duplicate elements. You don't want any duplicates if not words contained. So this means checking to see if the collection has this element or not. If this collection does not have that element, then you add to it. So this gives you the ability to add elements to it. It starts with index 0. So you're going to have words in it, words in it, words in it, because of this selection control statement. Guarantees that every single element inside this collection is unique. So as you loop through the number of words, every time there is a has next iterables, you increment the number of words. So this gives you a total number of words inside this text files, and total number of words as well as number of unique words. The number of unique words is basically counting the number of elements you have in this size. So this word size is number of elements you have in this collection. The vocabulary density is computed as a total number of words divided by the number of unique words. That is the density part.